Good morning, students. Now we are discussing complex compounds chapter. Next topic in that chapter is Werner's theory. This is very important theory in CBSE level and also in competitive level. Here only few points are there. That too only 4 points are there. We will discuss those points now. According to this theory, the metal in every complex compound possesses two types of valencies. They are primary valency and secondary valency. That means in complex compound metal ions ligands are present. In some complex compounds counter ions also present. We discussed those points in previous videos. So what is the point here? In every complex compound metal exhibit two valencies. They are primary and secondary valency. Next, this primary valency is always equal to oxidation state of central metal atom. That means in every compound metal exhibits some, not only metal, every element exhibits some oxidation state. So in this case also metal exhibits some oxidation state. Here that oxidation state is equal to primary valency. Suppose if oxidation state is plus 3, then primary valency is 3. If oxidation state is plus 6, then primary valency is 6. That means valency, whether it is primary or secondary, valency is always indicates with the numerical number without sign. We should not mention with the sign. But in case of oxidation state, we should mention with the sign. Next, this is denoted by dotted lines. When we discuss about the example, then you will get clear idea about the dotted lines. And here one more point is there, that is primary valency is always satisfied by negative ions. That means if in a complex compound negative ions are present, then those negative ions satisfies primary valency. That nothing but oxidation state of the metal atom. That is the meaning of the point. When we discuss about the structures, then you will get clear idea about the point. Next, secondary valency is always equal to coordination number. This is denoted by bar lines. Primary valence equal to oxidation state of the metal atom. Secondary valence equal to coordination number. What I told you already. What is coordination number? Number of dative bonds formed by ligand with the metal atom. That is called coordination number. In here, that coordination number is also called what? Secondary valence. That is denoted by bar lines. In case of primary valence, that is denoted by dotted lines. Next, here one more point is there regarding secondary valence. It is satisfied by negative, neutral, and rarely with positive ions. Primary valence is satisfied by only negative ions, but secondary valence is satisfied by negative ions, neutral ions, and rarely with positive ions. That means positive ligands are very rare in complex compounds. Next, every metal in the complex compound possesses characteristic secondary valency. That means every metal having fixed coordination number. There is no reason, there is no specific reason behind that one. For example, take zinc. That means if zinc metal is present in the complex compound, then its coordination number is 4. That means zinc can bond with 4 ligands. That is the meaning. It cannot form more than 4 ligands. Copper also 4 coordination number. That means copper also can form 4 ligands. Sorry, copper also can bond with 4 ligands. But chromium and copper, they can bond with 6 ligands. That is the meaning of that point. That means every metal has a fixed secondary valency. Only these are the 4 postulates regarding Werner's theory. Here there are some more points regarding Werner's theory. We will discuss those points now. See, when you see the structure CONH3 6 times Cl3, when you see the structure CONH3 6 times Cl3, in this structure CO is what? Metal atom. NH3, this is what? Ligand. And Cl3, that means 3 chloride ions, these are what? Counter ions. If you see that structure, see how many ligands? 6 ligands. First, what we have to do? We have to find oxidation state of cobalt. How to find? I will show now here. See, CONH3 6 times Cl3. First what we have to do, we have to find the oxidation state of central atom. That means it is X plus NH3. It has no charge. I told you already this is neutral ligand. So that in that case oxidation state is 0. How many ligands? How many ammonias? 6. 6 into 0 plus 3 into chlorine common oxidation state how much? -1. So finally x minus 3 equal to 0, x equal to plus 3. This is what? This is what? Oxidation state of cobalt, nothing but primary valency. So in this case primary valency is how much? 3. This primary valency 3 is satisfied by which ions? Negative ions. Here negative ions is what? Chloride ions. These ammonias are what? Neutral ligands. So these neutral ligands cannot satisfy primary valency. Only negative ions satisfy primary valency. So that we can draw the structure like this: CO plus 3 Cl minus Cl minus Cl minus. You can draw this Cl minus in any manner, like or here. There is no specific diagram for that. Next, here how many ligands are there? 6 ligands are there. These are neutral ligands. What is coordination number here? 6. Because ammonia is monodentite ligand. It can form only one coordinate covalent bond with the cobalt atom. So here 6 such ligands are there, so that its coordination number is 6. Even coordination number is 6, automatically secondary valency is also 6. Now our point is what? This secondary valency is satisfied by neutral, negative, positive. So here no need to consider negative because already 6 neutral ligands are there. So that we can draw by using the structure, secondary valency structure, by using neutral ligands. That is represented by which line? Bar line. So this is bar line. NH3. You can draw in any manner. NH3. How many ligands? 1, 2, 3, 4, 5. Still one is pending. You can draw either here or here or here. So this is the structure for this compound, this complex compound. That is the meaning of the point. Next structure. When we consider one more structure, CONH3 5 times Cl2. In this case, here also oxygen state is plus 3 because this is X, this is 0. Here chloride -1, here minus 1 into 2. Total here also plus 3. You can find it. And here plus 3 is what? Oxygen state. That is nothing but primary valence. That means that the primary valence is satisfied by negative ions. Here negative ions are what? 1 this chloride and 2 these counter ions. Total 3 chloride ions should be mentioned with the dotted lines. Then how many ligands are present here? 6 ligands. 5 NH3, 1 Cl. Total 6 ligands. Among them 5 ammonia dotted with ammonia represented with bar lines, and 1 Cl. This 1 Cl. This acts as a ligand. This Cl already represented with the dotted line. Again that also should be represented with the bar line because here this Cl is what? Negative ion. That negative ion satisfies both primary valency as well as secondary valency. Here secondary valency is also how much? 6. Among 6, 5 are ammonia and 1 is chlorine. That chlorine satisfies primary valency as well as secondary valency. That is why that one chlorine represented by dotted line as well as bar line. Next, one more structure, CONH3 4 times Cl2 Cl. In this case also cobalt oxygen state is what? Plus 3. You can find it because ammonia neutral ligand 0. Here 2 into -1 plus -1 is equal to 0. Total minus 3, x minus 3 equal to 0. X equal to how much? Plus 3. That means what? Oxygen state of cobalt. That is what? Primary valency. So that primary valency is satisfied by which ions? Negative ions. Here negative ions are what? Only chloride ions. So that those 3 chlorides should be bonded with, should be represented by dotted lines. Next here also coordination number is how much? 6. How? 4 NH3s and 2 Cl2, total 6. 6 is what? Ligand number, nothing but coordination number, that is also nothing but secondary valency. That means that secondary valency should be mentioned with bar lines. Here 4 ammonia should be mentioned with bar lines. See, this is one ammonia, this is one ammonia, this is one ammonia, this is. Then next two ligands are what? These chlorines. Again those two chlorines bonded represented by bar lines. See, this is one chlorine, this is one chlorine. So this chlorine, these two chlorines represented by dotted lines as well as bar lines. But this chlorine is only represented by dotted line. Why? Because in this case, in this complex compound, two chlorides are acts as ligand. That is why those two chlorides represented by dotted lines as well as bar lines. But this chloride, one chloride, there is counter ion, so that is not acts as ligand, so that it can be represented by dotted lines only. Next, take one more example. CONH3 3 times Cl3. This is neutral complex because in this complex there is no counter ion. So here also coordination number is 6. How? Ligand number 3 ligand, 3 ammonias, 3 chlorines. Total coordination number 6, nothing but secondary valence also 6. Next, here oxygen state is again here plus 3. How? Here 0, here 3 into minus 1. Total plus 3. Nothing but primary valence is also 3. So primary valence always satisfied by negative ions. Here negative ions are what? These chloride ions. So here these chloride ions are negative ligands here. Negative ligands. So what is the point? These chloride ions acts as ligands as well as satisfies primary valence. So that these three chloride ions represented by dotted lines as well as bar lines. But these three ammonias represented by only bar lines. These cannot be represented by dotted lines. Why? Because these are neutral molecules. These neutral molecules cannot satisfy primary valence. So that those substances can be represented by only bar lines. This is the structure of this compound. So this is the way to represent the structure of complex compounds according to Werner's theory. Next, there are some more points regarding this one. See, when we consider first compound, that means this one, when this compound reacts with AgNO3, then 3 moles of AgCl will be formed, because here in this complex compound 3 chloride ions acts as counter ions. Those ions only involves in reaction, so that Ag reacts with these 3 Cl. That means we should take 3 AgNO3, then we get 3 moles of AgCl precipitate. In this case, second case, only 2 chloride ions are counter ions. This chloride ion not involves in reaction because this acts as a ligand, so that this Ag reacts with these 2 chloride ions. That means here we have to take 2 AgNO3 molecules, then we get 2 moles of AgCl. In this case, CONH3 4 times Cl2Cl. In this case, only one chloride ion is counter ion, so that chloride ion only reacts with Ag. Then 1 mole of AgCl will be formed. Suppose if you consider this one, which one? CONH3 3 times Cl3. When you consider this one, that means when this compound reacts with AgNO3, then here no counter ions are present, so that this AgNO3 cannot react with this substance, then no precipitate will be formed. So this is also one of the important topic regarding this one. Here you may get 2 types of questions. One is, when this compound reacts with AgNO3, how many moles of AgCl will be formed? That is one model. One more model is there, that is, sometimes they give these 4 options. Out of these 4 options, which exhibit more conductivity in aqueous solution? There is also one more model. Out of these 4 molecules, nothing but 4 complex compounds, which exhibit more conductivity. What is the condition to exhibit conductivity? Either the substance should have free electrons or free ions. Here in this case, which condition we should consider? Free ions. That means when this compound present in water, then it gives 4 ions, 3 chloride ions, 1 complex ion, total 4. When this compound present in water, then we get 3 ions, 2 chloride ions, 1 complex ion. When this compound present in water, then we get 2 ions, 1 chloride ion, 1 complex ion. But when this compound present in water, we don't get any ion because this is neutral complex. So in which case more number of ions are present? In this case, so that this compound exhibit more conductivity. So that is also one of the model. Next, this is drawbacks of Werners theory. It could not explain shape of the complex compounds. Actually, generally we discuss shape as per electronic configuration, but here we have written their structures. Structure is different, shape is different. Shape means what? Octahedral, tetrahedral, those are the shapes. According to this theory, we cannot explain shapes of the compounds. Next, it could not explain color of the complex compounds. Next, it could not explain magnetic behavior. That means whether it is paramagnetic or diamagnetic. So by using this theory, we can't explain these properties. So these are the drawbacks of Werner's theory. So this is all about Werner's theory.